Hey, welcome to class 13. So today we're going to talk about file I/O in C. So reading from files and writing to files. We know how to read and write from standard in and writing to standard out. We do that all the time in C. So how do we output to standard out normally? We say printf. And there's some description that describes how things should be formatted, and then a list of variables. And to read from standard in, we say fgets, and we list some sort of array of characters, its length, and standard in. And, the reason this reads from standard in is because we've got standard in right here. The reason this writes to standard out is because it always writes to standard out. But this is really a shortcut for a more general function called Fprintf, whose first argument is standard out, and then, some sort of string, and then a list of variables. So input, we already read from standard in. If we could somehow put something different in here that referred to a file, we'd be able to read from a file. And fprintf, if we put something in here other than standard out, something that referred to a file, we could write into a file. So we're going to use fprintf, which is just like printf except for that first argument, and we're going to use fgets, and those will be our initial ways of doing output and input. So let me work with a new program, main.c. And here's my fprintf statement, and you can see my first argument is this thing called fp. So what is fp? It's declared to be a pointer to a file. We don't really need to understand what a file is or why we're pointing to it, but we need to know that anytime we want to do file I/O like this, we're always going to want to define something that points to a file. And it doesn't have to be called FP, that's just an abbreviation for file pointer. Again, it's just a variable name, it could be anything we want. But you'll often see it called FP for file pointer. So what can we do with that variable once we've declared it? Well, we can use it to get the result from calling fopen. And fopen is a thing that opens a file for reading or writing. So fopen, if we look at the manual page for it, fopen takes two arguments. The first is called a path name, and it's a pointer to a character, which means it's a string. What is a path name? It's the name of the file. It could be just, something like output.txt. Remember, that's a relative path name, so that means in our current directory. Or it could be something like, let's go ahead and put this in /tmp. And now we've got a whole path to this file, and that would be a file sitting up in that temp directory. And then the second argument is also a char star. It's a string, which means we're putting it in double quotes, and it's called a mode. And that basically says, what are we opening the file in order to do? And the main modes we're going to work with are W for writing and R for reading. So W will truncate the file to 0 length. It empties it out and lets us start writing into it. R will open a file for reading, starting with the beginning of the file. And there's other versions of this. We can open it for reading and writing, we can open it for appending, and so on and so forth. So look at the manual page for fopen if you want to dig into the details of that. So we're just going to open this file with a mode of W for writing and save the return from fopen in fp. So if we look at this manual page again, and we go down to where it shows the return value, upon successful completion, these functions return a file pointer, right? A pointer to type file. Otherwise, null is returned. All right, so fp is presumably a file pointer for writing into output.txt, so I'm going to use it as the first argument to fprintf, and I'm going to say hello world. And then I'm going to close the file by calling fclose. And that undoes what happened when we said open. So there's some exercises we'll do in class to play around with the effects of closing or not closing a file. But this is our simple program for exploring file operations. So right now all I have in my directory is that main program. So I can compile that program. Now I've got my main program and the executable program. And if I run it, it doesn't print any output, but it creates a new file called output.txt. And if I look at output.txt, it's a one-line file containing the string hello world. So it does exactly what we expected. And if I change it to say ha ha ha, and I compile it and I run it, and then I look at output.txt, it contains ha ha ha. And if I print multiple lines into my file, and I run my program and I look at my output file, it's got multiple lines in it. So if I had just said printf, or if I had said if fprintf standard out, then all of this would have been displayed on my screen. I would have seen exactly this. But instead of coming to my screen, it went into a file, right? So I could have, printed this on my screen and redirected output with a greater than sign, but this is a self-contained C program that creates this file, writes this information into it, and then closes the file. Right? So that's the creation of an output file and the writing to a file. All right. Now, when we looked at the manual page, it said that fp is the file pointer, but it could also be the value null. So upon successful completion, fopen returns a file pointer. Otherwise, null is returned. So let's see what fp is actually equal to. So let me clean up my code here. And let's print out the value of fp. And, it's a pointer. I should probably be printing it with a %p, but I'm just going to print it with a %d. And I'm going to leave the compile warning when I try to compile this. And let's just see what it's actually returning. And it's returning, some kind of unremarkable looking number, right? So let's make this a %p. And it's an equally unremarkable looking number. But if I run this multiple times, it seems to be a different number each time. So that's maybe noteworthy. So let's try and break this. Let's try and create an output file in the etc directory, the etc directory, which is a protected directory. And if I do this and I run it, it tells me fp equals nil. So if I print this back as a %d, and I run this, my fp is actually equal to 0. 0 is the value of null, sometimes called nil, and that's an error condition, right? It's a pointer. Pointer should never be equal to 0. So when I see a 0 coming back, I know that there's a problem. And if I try to write anyway, even though my file pointer is 0, I get a segmentation fault. So what can we do? We can take advantage of this and we can say, if fp equals null, we can print a message saying can't write to file, and we can return from our main program here. So let me throw some messages in here, some comments, try to open output file. Did we succeed? No. All right. So I threw a few comments in. It took, 20, 30 seconds to put those in, but it's going to help me down the road because now, when I get to this section of my code, I don't have to, dig through all of this code and figure out what fopen does and so on. Notice there's a W. I've got a comment trying to open the output file. And what am I doing here? I'm checking to see if we succeeded. And if this if statement is true, I know I didn't succeed. So this is all the stuff I'm doing if I did not succeed. If I get down here, I did succeed in opening the file. So now I'm going to continue my program. I'm going to go ahead and write. And then I might throw a message down here, done with file, close it. All right, so if I compile that, Well, I've still got my funny pointer there. Let me just get rid of that print statement, because that was just for development purposes. So I can compile this, and then when I run it, it tells me it can't write to the file. And if I change this to write to just our current directory, and then I run it, it works fine. And if I do an ls, I can see that, you know, right now, because right now is 7:09, at that time, the output file was created. And when I look at the contents of it, it's just that one line of ha ha ha. By the way, if I go back to trying to write in the etc directory, right, I can't write to that file. Why is that? Because if I look at slash, the root level directory, and I look at etc, it's readable by the world and it's searchable, but it's not writable. Alright, so if I try to run this program, it tells me it can't write to the file because I'm trying to write to this protected directory. But if I run this as a super user and say sudo /main, it succeeds. And if I do an ls and do an lrt to see reverse chronological order on the etc directory, sure enough, there's a file in the etc directory now called output.txt. And if I cat /etc/output.txt, it's got my ha 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 in it. So this business of, you know, do you have permission to write a file depends on where the file is. It also depends what your user ID is. If I tried to do this in another user's account and I wasn't a super user, I would get the same permission error. Similarly, if I change the permission on this file so that it can't be rewritten, and then I try to modify it, I'll get an error from that also. So I'm going to remove that, because you notice that file is owned by root. So if I try to remove it as myself, it won't succeed, but I'll remove it as a super user. And then if I try to cat it, it's not there anymore. All right, so we want to, you know, make sure that we look at the output from fopen before we start trying to write things, to make sure that we were able to access, get a valid file pointer for doing our operations. So let's look at the input side now. So let me, let's just open test file, and let's open it for reading. And again, I'm going to see if the file pointer is null, and if it's not valid, I'm going to say can't read from the file and exit. Otherwise, file is open. Go ahead and read. And I'm going to say fgets, and I'll make a character array called buffer. I'll make it 120 characters, and I'll read instead of standard in from fp, and then I'll say printf read from the file, and I'll do a %s to see what I read in from the file, and I'll just print out my character array named buffer, and then I'll go ahead and close the file. So let me make a character array, and so here's, you know, a hello world for reading from a file. Open up the file for reading, make sure that we were able to open it, and then call fget, same as we used for standard in, but instead of saying standard in here, say fp. So read one line into this character array buffer, and then let's print it out and see what it looks like. So let me come over here and let me compile this and run it, and it says can't read from file. Why is that? Because there's nothing in here called test file. So let's make a test file. So there's a 5-line test file, and we'll go ahead and save that, and then we'll go ahead and run our main program again, and this time it says I read from the file, and the line it read was this is a test. So I was able to read the first line from the file. Alright, if we look at the manual page for fgets and we look at the return value from it, it tells us at the bottom fgets returns s on success, right, where s is the thing that we passed to fgets. So fgets takes a character array. So it returns back the address of that array if it succeeds in reading a line. But it also says it returns null on error or when end of file occurs. So we can detect when we've read past the end of the file by looking for EOF. So let's modify this program a little, and let's make an infinite loop. So I'll just say while 1, and 1 is always true. And we'll just keep reading. And let's compile that. And let's run it. And you can see it reads the last line, but then it just says, you know, read from the file by, and it just keeps doing that. It's stuck reading the last line again and again. So what we can do is we can say car at status equals fgets. And we can say if status is equal to null, then let's break. So we leave the loop. Otherwise, we'll go ahead and we'll print out the line that we read and go back up to the top of the loop. So this is one way to process a file up to the end of the file, is to make an infinite loop and put an exit condition to get out. I'll show you a perhaps cleaner way to do that in a moment. But let's just try this first. We'll compile it and we'll run it, and sure enough, it reads exactly 5 lines from the file, and then at the end kicks out of the loop. And if you put a message down here, done reading the file, we can confirm that it actually did leave the loop in a controlled way. So we always want to check the return value from fgets to see if we actually read a line of information from the file, or if we hit the end of the file. So, you know, infinite loops work fine, but they're not always exactly what we want. So we might do this a little differently. We might say while and we could take fgets and take the return value and store it in a variable, but all we want to do with that variable is know, did fgets return null? So we could say while null is not equal to fgets, and use that as our condition for our while loop. So this does 3 things. It tries to read a line from the file. It compares the return from fgets to null to see if it succeeded in reading a line, and then it decides whether to continue with the body of the while loop or whether to exit. If there's a line of data available, it's not null, we'll go ahead and we'll execute this body of the loop. But if fgets returns null, this condition will fail, and we will exit the while loop and come down here. And so this is a type of statement you'll see a lot when there's file I/O happening in code, and when we run this, it works, you know, exactly the same way. So that's a sometimes useful way of doing controlled file I/O up to the end of the file. All right, last thing I want to talk about here is low-level I/O, and you'll get more of this in a future course. This is really getting into a system programming area. But since we're talking about file I/O anyway, it's worth taking a quick look at it. So if we do a man on fopen, we see this number 3 up here. Chapter 3 of the manuals are functions that are sort of high level, things that we would typically call from a C program. Chapter 2 of the manual is for the low level functions, system functions, functions that we probably wouldn't call under most circumstances ourselves, but that are used by other functions. And so one function we can find in chapter 2 is open. And open is a low-level way of opening a file. It's actually a function that's used by fopen. So remember modularization that we talked about in class 11. When we write the fopen function, because, you know, we're creating Linux ourselves, we use the open function to actually do the low-level I/O to the disk of a file, and fopen is just the extra stuff we add to work with, you know, the user the way that they expect to interact with this function. So we can look at the manual page for open, and we notice that we have to include 3 files, which I'm including over here, in addition to standard I/O. And there's an open function. It takes a path name, so that's the name of a file. It takes a set of flags, and it takes a mode. And this is a more complex function to use. The reason fopen exists is because fopen is pretty straightforward, right? Give it a file name, say quote W, and you're opened for writing. But to use the open, we have to give it a path name, but we also have to specify a flag and a mode. And if we move down through the manual page, we can find a number of flags, one of them being O, read only, read write, write only, and so on. O underscore append, O underscore async, O underscore CLO exec, and so on. There's create, which says create the file if it doesn't exist. And each of these is a bit mask. So if you've done Engineering 270, we talk about bit masks. These are all different binary patterns. And the way we use these is we OR them together. So that's what these pipes are. And this line is saying I want to create the file if it doesn't exist. I want to open it for writing, and I want to truncate it to a size of 0 if it already has stuff in it. So that combination of 3 masks gets ORed together, and it gives us a bit mask, which corresponds to the behavior of, you know, basically opening our file the way we would with a quote W from fopen. And then the mode, this is the mode in which we want to open the file. And if we search for that pattern, we see that that gives us a permission bit of 700. User has read, write, and execute permissions. We don't really need execute, but you know. So that's how we open the file. And then if we look in manual section 2 for the write function, we see we need to include this library, Unix standard, so we include that also. And write takes 3 arguments. The first one is this integer file descriptor that open gave us. The second one is a character array, or you know, an array of something, right, called buff. And the third is how many bytes we want to write. And we could spend, you know, a few classes just digging through these functions, looking at return values and so on. But we're going to just use the write function and say write into this file descriptor, write the string hello for 5 characters. And then there's also a manual 2 function called close, which just takes a file descriptor. So this is like fopen, this is like fprintf, this is like fclose, but these are low-level functions, right? And they're good for doing, for example, binary I/O, where you might be writing special characters that you don't want treated differently. For example, when you write a new line on some systems, it also outputs a carriage return. On some systems, if you write character ASCII code 26, it marks the end of the file. This is very low-level binary I/O. So with this set of code, I can say gcc-o main.c. Let me make sure I save this. And then if I say main, it creates this file called new output. And if I remove that and I run main, there's the new output file. And if I do an ls-l, I can see it's got my 700 permission, and it's exactly 5 bytes. And if I edit it and say vi new output, there's my 5 bytes. It says no end of line. It's one line, 5 bytes in length. There's not a new line at the end. Now normally when I make a new file like test and I say hello and I do an ls-l, test is actually 6 bytes. And if I vi the file, it tells me it's one line, but it's 6 bytes. There's a new line sitting there at the end. But since I'm doing this low-level binary I/O, my new output file, it just ends with that letter O, and there's no new line. So there's a nice command, xxd, which we can use to look at our files at a very low level. And if I xxd new output, I can see over here the ASCII codes for each character in my file, 48, 65, 6C, 6C, 6F. That's HELLO, and that's all that's in there. Whereas if I XXD the file test, I see an extra byte at the end, 0A. That's ASCII character 10. That's the new line character. And you can see over here it printed a dot to show me the contents of that, that part of the file. So we could spend a lot of time digging into the details of this, but for example, if I get rid of this create flag in the beginning, and I run main, and I do an ls, that's totally fine. We've got our new output file. But if I remove new output file, and then I run main, and I look, it does not create it, right? It wasn't there to begin with, and so it did not write it. But if I put that create flag back on my open, and I run that, then even though the file didn't exist, it will go ahead and create it. And so these flags have different meaning, and like I say, we could spend a lot of time digging into that, but you can look at the manual page for open, and it's got a lot of information in it. And you know, that's why we have section 2 functions and also section 3 functions. The things in chapter 2 are very low level. They're very powerful, but they take, you know, a lot of work to use. You have to specify bit masks, and you have to include a lot of support files and so on. Whereas the chapter 3 functions tend to be more streamlined for us to use. For example, to open a file with fopen, it's one call, fopen, file name, quote W if we want to write, quote R if we want to read, and it's all set up in standard I/O. So that's just a taste of things to come as far as low level versus high level. We probably won't need to do a lot of anything with these low level file I/O functions. But if we wanted to do, for example, network input and output, it's useful to work down at this level of these low level system functions. All right, so that's a basic overview of file I/O.